Welcome back, mathletes, to another episode of Math with Dr. Math. And today we're going to talk about that factor theorem.
Oh yeah!
All right, so let's go ahead and let's look at this factor theorem and let's read all about it. All right, so here's what it says. It says, let f be a polynomial, f of x be some polynomial, all right? And if the following happens, right? So if f of c, so if you take some constant and plug it into f, right? If you get 0 as your output, what that tells us is that x minus c is a factor of f of x, all right? Likewise, right? If x minus c is a factor of f of x, then f of c equals 0. All right, what does this all mean? All right, so again, don't just read these theorems, really take your time and try to understand, what the heck are these theorems and these definitions telling us? Because sometimes you need a definition for the definition, right? Because it seems very abstract. All right, so make sure you dive in here because I don't want you to end up like this guy.
Wow.
All right, so here we go. Here's a quick little example and then we'll dive into some other ones. But let me just quickly write this one down for you. Let's say you have f of x as, let's take something we know how to factor quite easily. So let's say x squared minus 25, right? So we know how to factor that, and just so we could kind of understand this theorem here. So if I were to factor this, it's a difference of squares. That's x plus 5 and x minus 5. And if I really wanted to find the zeros, right, the x-intercepts, all I would do is I would set this function equal to 0. Right? So I'll set this function equal to 0, and I get x plus 5, x minus 5. And then what I would do is I would then take each factor, right? Take each one of these mother factors and set each one equal to 0. So I'll take that x plus 5, set that equal to 0, solve, x minus 5, set that equal to 0 and solve. And so we'll get two solutions here, right? Negative 5, that's one of my zeros, and positive 5 is another one of my zeros. So according to this theorem here, we know, and we already know this by solving it, but what we're going to see is not everything is going to be this easy to factor, right? We're going to get into some beast mode polynomials, and you're really going to need to understand this theorem. If not, you're going to be busting your head trying to factor, right? In some cases, you just can't, but in other cases where you can, this is going to help you factor without just developing some headaches. All right, so what this is saying, this theorem, let's say part 1 is saying, I know that 5 is a 0. So let me say, so if f of 5 equals 0, which we know it does for this function here, then what this theorem tells us, so if we know that 5, and let me put that in a different color here. So 5 here, put that in red. If 5 is a 0, what this theorem tells us is that x minus 5 is a factor of f of x. And we already know that to be true because we factored this. So all this theorem is saying is you give me a constant, right, that's a 0, and then what I'll tell you is I'll use that to find the factor of that same polynomial. All right, so once you have one, boom, you automatically have the other. And this works both ways. And that's what part 2 is all about. Part 2 is saying, well, let's look at what we did here. Notice I factored it. So let's say that we know x plus 5 is a factor. So what part 2 is saying is if x plus, and let me write that 5 here. If x plus 5, I gotta be careful. Let me put, I could write it like this, and notice I could also write it, that's an or, sorry, as x minus negative 5, and I'll tell you why I'm doing that right there. So if x plus 5 is a factor, what this theorem is saying, it's saying that then f of something equals 0. And the reason I wrote this in the form is because look at the form they give us. They give us x minus c. So that's why I wanted to write it as x minus some number, because that number right here, that's going to be what goes inside here, because we're always taking the opposite, right, of whatever's right here. So f of -5 is a 0 by this theorem. So again, all it's saying is, you give me a factor and I'll tell you what the 0 is. Or you give me the 0 and I'll tell you one of the factors of f of x. All right, and this is going to be very helpful as we move forward. All right, let's dive into some examples here. All right, so let's go ahead and look at this question and then we'll dive into the solution. So here we go. Use the factor theorem to determine if the given polynomials are factors. All right, so here's our initial polynomial, and what we want to know is, are these right here factors? Are these polynomials potential, right? Are they factors of this right here? All right, and if I didn't have these theorems, this would be really long. I would actually have to factor this and see if this would come out. But I have some tools now. All right, so let's look at the solution here. So let's look at part A first. All right, here we go. So if f of 3 equals 0, right, that's what that theorem was saying. If f of 3, right, I take the opposite of this number and I plug it into my function. If f of 3 equals 0, then what we are going to know is that x minus 3 here is indeed a factor of f of x. So I'm going to go ahead and use synthetic division because I find it a little faster, right? Is it faster all the time? No, sometimes I could just plug in the number, but I want to get comfortable and practice with synthetic division. All right, so we'll go ahead and use synthetic division here. Notice all we did was list the coefficients, just like we did in our synthetic division video. That's linked down below. So here's our coefficients. So the 1, we know we drop it down. We multiply, you get 3. You add these, you get 2. You multiply, you get 6. You add these, you get -5. You multiply these, you get -15. You add them, you get -4. You multiply, you get -12. You add them, and you get 0. Notice, when we plug in 3, right, f of 3 gives us 0 here. So what does that tell us? Well, by the factor theorem, since f of 3 equals 0, since we did get a 0, that means that x minus 3 is a factor of f of x because we got that 0 there. So now we know that if we wanted, we could actually divide this function, this polynomial, right, by x minus 3, and you'll get no remainder because x minus 3 is a factor, right? And again, we're going to use this in so many different ways. Sometimes we'll use it to break down polynomials, and sometimes we'll use it to find zeros of polynomials. So very useful theorem here. All right, part B here. So again, for your just so you could recall, this is our original function, and now we're asking, is x plus 2 a factor? So when they're asking if f of x plus 2 is a factor, what you're really doing is you're plugging in f of -2, right? Always the opposite here. You plug in f of -2 into the function, and you're analyzing. You're seeing, is my output, what do I get? Is it a 0? All right. And again, I'm just also using the remainder theorem in combination with this factor theorem so that I could save some time and I don't actually have to plug in the -2. And instead, I can use synthetic division. All right, so here we go. So using synthetic division, here's what we have. So I'm going to plug in that -2, and I go to work here using synthetic division, right? You know how to do synthetic division. Here's our work. So what we want to focus on is that remainder, right? Because that remainder actually is your output when you plug in -2. So our output, when you plug in -2, we would get -30. And because, right, according to our factor theorem, since f of -2 is not equal to 0, what that tells us is that x plus 2 is not a factor of f of x. So again, very powerful little tool, very theorem here. All right. Any questions yet? All right, let's continue. All right, so just to make sure that you know what's going on and you're just not like this. I see that all the time in class with my students. You got to get some practice in. All right, we got to work. So this is what we're going to do. You're going to press pause right now and you're going to try this before we move on. So here's your practice problem. So you're going to use the factor theorem to determine if this polynomial here, right, has the following factors. So first you're going to check if x minus 6 is a factor. So go ahead and rewind the video, but you need to practice this, right? It's like you watching someone lift weights and you're like, oh yeah, I got it. You got to do the work, right? Or else the results will not come. All right, so go ahead, press pause, and you're just going to say yes or no, do the work, and we'll show you the answer in a few seconds. All right, so here are the answers right here. So for the first one, it is a factor. The second one is not a factor, right? If you still have more questions, it's your job to comment down below, right? We can't read your mind. I ain't a mind reader. So let's get going. Let's dive into some more examples here. So let's look at this guy right here. All right, so factoring a polynomial given a known zero. Sometimes we might know one of those zeros, right? We're gonna see all kinds of different situations, right? So in this example, they want us to factor this cubic function given that -5 is a zero of f of x. All right, because maybe I look at the function, maybe I graph it into my calculator, and one of the factors is actually pretty nice. It's one of the zeros is pretty nice. It's -5. Well, I could use that, and I could use that zero to find the rest of the zeros. How? Let's take a look. All right, so the value of -5 is a zero of f of x. That's what's given to us, right? So what that means is that when I plug in -5, just like I said, into the function, that equals 0. So according to our factor theorem, right, that means that x minus -5, which is the same thing as x plus 5, is a factor of f of x. So what I'm going to do is I'm going to use synthetic division, and synthetic division is going to help me find my other factors. All right, so here we go. We use synthetic division. We grab that -5, and we grabbed all these coefficients, right? And we just use synthetic division. We already know that we're going to get a remainder of 0. What I really want is these right here, because these are going to be my coefficients for my next polynomial. So notice our original polynomial was x to the 3rd power. So these, when I rewrite this, look what it's going to turn into. It's going to turn into 3x squared plus 10x minus 8. And so that's a polynomial that I get when I divide, right, this original function by x plus 5. This is my result because I already know that x plus 5 is a factor. And what I hope to do is to factor this further to get the remaining factors, right? So again, very helpful theorem. So let's go ahead and factor this. And again, we'll be linking down videos down below to help you factor, because if you can't factor, this is going to be very challenging. All right, so let's go ahead and factor this. And so we end up with is 3x minus 2 as one of our mother factors and x plus 4. All right, so again, make sure you get that practice down and make sure that you know how to factor. All right, I do not want to see you ending up like her.
Stop! I can't breathe.
All right, so there's our factors. So if I were wanting to factor this original polynomial, my 3 factors would be x plus 5, of course, 3x minus 2, and x plus 4. And there we have it. Now we know that this original function, it factors completely into this right here. So again, very helpful tool. All right, so before you go away, let's do one more. all right? Don't fall asleep on me. One more. All right, so let's take that same question and let's go even further. So now let's say that we actually want to solve this, a polynomial, but we want to set it equal to 0. Because again, we want to actually do something with this, right? Factoring is just a tool to help us answer some further question, right? So here we have our equation here, and what we do is we set it equal to 0. So to solve this equation, we know we're going to set one side equal to 0. That's already done for us, right? If it's not equal to 0, you make it equal to 0. You're going to see that from time to time. All right, so we're going to factor this, and the nice thing is we already did the work, all right, earlier. We already showed you how to factor it. So now, since it's factored nicely, we're going to set each one of these mother factors equal to 0. So here I'm going to subtract 5 from both sides. Boom, we get x is -5. Here we're going to solve for 0, add 2, then divide by 3. Boom, we get x equals 2/3. Then we're going to subtract 4 for this one for both sides. Boom, x equals -4. All right, so we went ahead and set each one of those factors equal to 0, and these three solutions make up our solution set. So now we know that if we were to plug in any given one of these, right, into our original function, you would get that equal to 0. And there you have it, folks. Right, follow those 325 steps and you're done. All right, folks, if you have any questions, make sure to comment down below. Don't forget to like, subscribe, because we're working hard behind the scenes for you. All right, mathletes, peace.